Okay guys, in this video we're going to be discussing what we call coterminal angles. And so let's go ahead and get started with just this vocabulary term, coterminal. When we refer to an angle, of course, usually we refer to them as being in standard position, and that is to say that they are having an initial side on the positive x-axis here. We often describe angles as rotating clockwise or counterclockwise. Let's just say that I had some angle here that was like greater than 180. So we'll call this like a 230 degree angle here. Fact is, maybe if I had a different angle, and let me put this in a different color here, that were to terminate in the same spot, so actually starts in the same place but maybe goes this way and has a negative rotation here, I say, well, what would this angle be that would terminate in the same spot? Well, one thing would be true about it. These two angles we would say are coterminal with one another. And the reason being is just because they kind of terminate in the same spot. So one thing we want to recognize about coterminal angles is that it says here, actually, increasing or decreasing the measure of an angle in standard position by an integer multiple of 360 degrees results in a coterminal angle. And so that is to say that if I were to say, take my 230 degree angle here, and let's say perhaps subtract off any whole number multiple of 360 or add on any whole number multiple of 360, remember a 360 degree rotation is just all the way around one time. So for instance here, 230 minus 360 here, I suppose, let's see, 360 minus 230, we'll do it this way, 360, well, 230 minus 360, 230 minus 360 here, we would get a negative 130 degree angle here. And so this would be a negative 130 degree angle that you see right here. And we would say that two angles, the first one 230 degrees, and the second one here, we'll call this theta 1 and theta 2, with negative 130 degrees. We would say that these angles would have to be coterminal with one another because they just terminate in the same spot. So the key here is just that if I'm ever given an angle and I want to find an angle that is coterminal with the given angle, all we really need to do is add on or subtract off or increase or decrease the original degree measure by any integer multiple of 360 degrees. And by integer we just mean whole number multiple of 360 degrees. So we say thus an angle of theta degrees is always coterminal with angles of theta degrees plus or minus 360 degrees times some k, where we're going to say k is just a whole number there. We could also look at this in terms of radian measurement. We could say increasing or decreasing the radian measure of an angle by an integer multiple of 2 pi, which in radians is the same thing as a 360 degree rotation. This would result also in a coterminal angle. Thus, any angle of theta radians is coterminal with any angle of theta radians plus or minus any multiple or whole number multiple of 2 pi rotations. So what we're going to be doing here is just kind of investigating how we could find coterminal angles by adding on or subtracting off multiples of 360. So looking at this checkpoint 5 here, what I've got are a couple of angles, and it says, would you please and thank you find a positive angle that happens to be less than 360 degrees that is coterminal with each of the following. So if it's positive, it's greater than 0 here, but it's also fair to say that they want it to be less than 360 degrees, so within one complete rotation here, but it has to be coterminal with the original angle. So when we talk about a 400 degree angle here, 400 degrees, of course, that would be like a full 360 degree rotation, so it would start here at the origin, and it's positive, so rotate counterclockwise, but 360 degrees, and then like another 40 right here. And so our 400 degree angle looks like this. This is 400 degrees right here. Well, we want a coterminal angle with this, but it's got to be less than 360. So what we'll do is we'll just say, well, let's take our initial 400 here. We'll subtract 360 degrees off of it, and we should get a coterminal angle. So here's our coterminal angle that does actually satisfy the fact that we wanted it to be positive, but less than 360 degrees. And one thing I want you to see here is, and I suppose I could switch my color back over to like a greenish color here, but that if we were to go and sketch a 40 degree angle, this 40 degree angle right here would terminate in the same position as our 400 degree angle. So taking a look at a negative angle here, negative 135 degrees, well, we know that this would be going clockwise here, a negative 90 at least right here. This is negative 180 over here, so negative 135, as a matter of fact, kind of splits the difference perfectly between these. So we say here's our initial angle right here, this negative 135 degree angle. Well, we want a positive coterminal angle, so this negative 135, what we'll do is we'll just add on 360 degrees here. And so what we get is, and I'll check this on my calculator, slide this over here, is we wanted to, and that's a degrees symbol there, we take a negative 135 that we were given and just add on multiples of 360. And we shouldn't have to add on very many. As a matter of fact, adding on just one 360 degree angle gives us a 225-degree angle. So here's our coterminal angle here, and just to kind of illustrate this, if I were to go actually sketch a 225-degree angle in standard position, it would start on the positive x-axis and it would rotate counterclockwise 225 degrees, which would be 45 degrees past our 180 here. So you can see that these two angles actually terminate in the same places. So looking at this with degrees, a little bit easy to do. You either add on or subtract off 360 degrees. When we look at something that is a radian measurement here, we're going to have to add on or subtract off, like we set up here, multiples of 2 pi, whole number multiples of 2 pi. So let's take a look at the instructions here. It says find a positive angle that's less than 2 pi, so kind of like saying less than 360 here, but that is coterminal with each of the following. So we start with this 13 pi fifths radian measurement here. And so 13 pi fifths, well, what I want to say is this. If we're doing pi fifths, over here is pi, so we would have 5 fifths of pi, or 5 pi fifths. This would be 10 pi fifths. If I'm sketching this, it would be all the way around, so 10 pi fifths plus another 3 pi fifths, which if we can imagine this being split up into 5 equal sized pieces up here, we would say that all the way around, okay, plus let's see, 1, 2, it'd be somewhere over in this quadrant right here in quadrant 2. So here's our 13 pi fifths that we see right here, 13 pi fifths. What we want to do is find a coterminal angle that's less than 2 pi, that's coterminal with this. So we're going to have to subtract off 2 pi here, since we've already gone past 2 pi, in order to end up with the coterminal angle that's less than 2 pi. So if I take off 2 pi, the thing that makes this a little bit different is with radian measurement, we're going to have to find a common denominator here. So in this particular instance, I suppose we would say 13 pi fifths minus 2 pi wholes. We would have to take the top and the bottom of this by 5, multiply by 5, and so we get 13 pi fifths, okay, minus 10 pi fifths, and that would just leave us behind with just 3 pi fifths. And so here's our coterminal angle that's less than 2 pi. And we could see that here, if we were to sketch a 3 pi fifths radian measurement here, imagine that from 0 to pi being split into 5 equal sized pieces, 3 pi fifths would land us somewhere right over here, actually land us right in the same place as this angle that we started with here. So now our negative pi 15ths, let's take a look at it now. If I were to sketch just a negative pi 15ths here, we would have to say, well, you know, starting at the origin right here, we're going to rotate clockwise, and we have to imagine between 0 and negative pi, splitting this into 15 equal sized pieces. I just know that it would probably terminate somewhere over here. So it would be 1/15th of a rotation between 0 and negative pi. So we say this is negative pi 15ths. We want to find a positive angle that terminates in the same place. So we're going to take our negative pi 15ths here, and all we'll do is we'll add on a 2 pi rotation, which is a 2 pi wholes rotation. We also need to take this and get a common denominator. So if I were to say take the top and the bottom of 2 pi over 1 times 15, I would get now 15 times 2 pi, which is 30 pi. 15 times 1 is 15. If I add together negative pi plus positive 30 pi, I get a positive 29 pi 15ths, which is definitely less than 1 full rotation, and would be this angle measure that you see here, this 29 pi 15ths, almost 30 pi 15ths, which would have taken us all the way around once. So after taking a look at coterminals with degrees and radians here, let's take a look down here where we get a little bit more exotic angles. We say find a positive angle less than 360 or 2 pi that's coterminal with each of the following. So same instructions as last time, except for, I want you to notice this here, this 855 degree angle, that's 855. If I want to find a coterminal angle that is less than 360, what I'm going to have to do is take off multiples of 360, so like this right here, but this is still not less than 360. I'm actually going to have to take off another 360 here until I get down to something that's coterminal. So we'd say 135 degrees is less than 360, and it's coterminal with 855 because we subtracted off 360 twice. Now this 17 pi thirds, keep in mind that if we're dealing with pi thirds, 6 pi thirds is the same thing as 2 pi wholes. Okay? So what we're going to be doing is subtracting off 2 pi increments or 6 pi third increments until we get down to something that's less than 2 pi. If I took away 6 pi thirds off my 17 pi thirds here, then I would end up with 11 pi thirds, and that's still greater than 6 pi thirds, which is 2 pi. So we're going to take off another 6 pi thirds here, which would leave us with 5 pi thirds, and 5 pi thirds is less than the 6 pi thirds or the 2 pi that we wanted to keep it less than. So here's our coterminal angle here. And then with respect to this negative coterminal angle here, we have negative 25 pi sixths. Well, what we're going to want to do is add on increments of 2 pi until we get to something that is positive but less than 2 pi. So keeping in mind that if we're dealing with 2 pi and we're dealing with sixths here, 12 pi sixths would be the same thing as 2 pi. So if I'm going to add on 2 pi, I'm really adding on 12 pi sixths. And so to add 12 plus a negative 25, that'd be a negative 13 pi sixths. We have to add on another 12 pi sixths here, and we would get a negative pi 6 left over, but that's still not positive and less than 2 pi, so we'll add on another 12 pi 6, or a full rotation here, and we would end up with just 11 pi 6, which would be less than 12 pi 6, or the 2 pi that we wanted to keep it less than here, but also positive and coterminal with the original angle. So in terms of coterminal angles, just means that they terminate in the same spot, and we can obtain these by adding on or subtracting off full rotations in terms of degrees, 360 degrees every time, or adding on or subtracting off 2 pi radian rotations if we're talking about radians.